Okay, so now for our last example, if you're watching this, this is the continuation of curve sketching that we started before. I want to graph this lovely little function. Y is equal to e to the x over 1 plus e to the x. And you can see I labeled the top and u and the bottom v because I'm going to take the derivatives to do my quotient rule here in just a minute. This one's going to be kind of fun. It's going to have some real interesting little pieces. First, note that the domain is all real numbers. E to the x is a function that is always positive. So 1 plus e to the x is certainly always positive. So this whole thing is just, we can use everything we want. So now I'm going to start piecing together the derivative. So I have my derivative of the top, it's just e to the x, derivative of the bottom is also e to the x. You'll notice I have the second derivative down here because I ran out of room over here. So let's get started. This one's a mess. And your ability to pull this one off very well is going to require you to do some really creative factoring. So the first derivative then is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now that's a bit of a mess, and you're going to be very tempted to distribute this e to the x into the parentheses, but I want to, or even to multiply those two together. I want to encourage you here not to though, because here's what I notice. This first piece has an e to the x. The second piece certainly has an e to the x. I'm going to factor that out instead. When I do that, when I pull that e to the x out, I'm left with 1 plus e to the x and then minus e to the x. Those e to the x's then drop out. And so we just get e to the x over 1 plus e to the x squared. That's much nicer looking than probably what's going to happen if you start multiplying all that out. So I need a second derivative. Again, I'm trying to get all of these things in place so that then we can just go right through the rest of the problem. Top is u, bottom is v. I took their derivatives. The derivative of the top is just e to the x. Derivative of the bottom, it's a chain rule. So I dropped the 2 down front, 2 times the inside piece, times the derivative of the inside, which is just e to the x. Again, you might be tempted to multiply that out. I'm going to encourage you to just wait. Because when we piece together that second derivative, here's what we have. We have the bottom times the derivative of the top, which is just e to the x, minus the top times the derivative of the bottom, all over 1 plus e to the x to the fourth. And now what I notice is that we have this subtraction here in the middle, both parts have an e to the x, and they both have a 1 plus e to the x. So I factored both of those out, which for the first part just left me with one of these 1 plus e to the x's, and then minus, this one got pulled out, 2, and then the parentheses are gone, e to the x. Which all allows it to combine then to be, well, first of all, the e to the x and minus 2 to the e to the x make 1 minus e to the x. And then we can cancel one of these, leaving just 1 plus e to the x to the third on the bottom. So that's a little bit nicer looking than it could be otherwise. So I hope your factoring and your algebra skills are really up to grade here because, oh boy, some of this is going to be kind of crazy. All right, so we have our two derivatives. Now we're ready to start launching into this and see what we can figure out. So let's get started. Okay, so continuing on. And you'll notice I brought the first and second derivatives over. I'm going to have to talk about those a little bit. So let's start looking for critical points. There aren't any. Here's why. In order to get a critical point, you either need a place where the derivative is 0 or where the derivative is undefined. In this case, that means either the numerator is 0, which would make the derivative 0, or the denominator is 0, which would make it undefined. Well, e to the x is never 0. So the derivative can't ever be equal to 0. And 1 plus e to the x is certainly always bigger than 0. So we don't have any zeros here for either the top or the bottom. We have no critical points. But note that y prime is always going to be something bigger than 0. E to the x is a strictly positive function, as is then 1 plus e to the x. So everything here is strictly positive. There's no way to get any negative values out of this first derivative. So we have an always increasing function. For the inflection points, this gets a little bit more interesting. We actually will have an inflection point. Again, it's going to happen where either e to the x, 1 minus e to the x, or 1 plus e to the x is equal to 0. because that would either make the second derivative 0 or would make it undefined. But as we mentioned up above with the first derivative, e to the x and 1 plus e to the x can never be 0 because e to the x is strictly positive. But 1 minus e to the x, that can be 0. So I set it equal to 0. I added the e to the x to get 1 is equal to e to the x, which means x has to be 0, right? E to the 0 power would give us 1. When I plug that in, I get a y value of 1/2. So I do have an inflection point now at 0, 1/2. And it turns out that's going to be the only point that we put on the graph, because that is also my y-intercept. And, well, we also can't have any x-intercepts. So, yeah, this is really quite the interesting little problem. We can talk about the concavity. If you plug in points on left and right of 0, you'll get that the second derivative is positive from negative infinity to 0 and negative after that. So it's going to be concave up from negative infinity to 0 and concave down from 0 to infinity. All right, so I think at this point we're ready to actually go ahead. Oh no, we have to do one more thing. We have to talk about some asymptotes. Put that on the next board, hopefully along with the actual graph. Okay, so here is our last board for this particular problem. You'll notice I brought forward the inflection point slash y-intercept because they were the same thing of 0, 1/2. We know that this function is defined for all real numbers. We already said that. So there can't be any vertical asymptotes, which just means we need to look at its end behavior. What happens as x goes to positive or negative infinity? So we're going to get a little bit creative here and have some fun. Let's look at the limit as x goes to infinity of e to the x over 1 plus... Actually, let's look at the other one first. This one's at... Well, yeah. Let's look at that one. Let's look at x goes to infinity first. So e to the x over 1 plus e to the x. I'm going to be a little bit clever here. I'm going to divide everything by e to the x. Remember, we had this thing that we did with rational functions before, where we divided by the highest power of x. I'm just kind of doing the same thing, only I'm dividing by e to the x for everything. When I do that, I get 1 over e to the x plus 1. Well, we know that e to the x goes to infinity. That is its limit. So really, this limit is... So 1 over e to the x is going to go to 0. If e to the x is going to infinity, 1 over e to the x is certainly going to 0, which means this limit has to be 1 over 1 or just 1. As x goes to negative infinity, e to the x is going to go to 0. For the same reason, because x going to negative infinity is the same as x going to infinity here. Because if you're raising e to negative powers, it's like 1 over that. So you're going to get 0 for both of these. So you end up with 0 over 1, which is 0. So a little bit of fun, a little bit of trickery there to try and figure out those two things. So what ends up happening is we have two horizontal asymptotes here. 1 as it goes out to the left, or I'm sorry, 0 as it goes out to the left, and 1 as it goes out to the right. And so you can see I have the dotted line at 1 for my horizontal asymptote. I'm using the y-axis, or sorry, the x-axis for my other horizontal asymptote. And there's my inflection point at 0, 1/2. So it just comes in along the y-axis. I keep saying y-axis. Comes in along the x-axis. Is curving up ever so slightly, so it's concave up. Hits that point, and then it curves down ever so slightly as it levels out to go along that line at y equals 1. So there you go. That was a pretty fun and exciting graph. Enjoy. Have a good day.